I'm going to first ask the panelists to come up. They'll take their seats. Then I'm going to ask each of them that first question, really, just to see what they think about what I just said. And that, you know, and this is as I mentioned, a distinguished panel with a lot of different opinions, I think. And I think managing it is going to be a challenge, but I look forward to that. So let me invite the panelists up. Lior Frankel, and then I'll give them an opportunity to introduce themselves when they get up there. Xavier Mesrobian, Del Peterson, somebody else. Again, that's a joke. It's Albert Roy Akers, I'm sorry, and Rich Carpenter. Okay? And by the way, you guys can thank me. I got you all water.
Thank you.
Because I was getting very thirsty in the last session and there was no water. So. Okay, so just as I mentioned as a kickoff for this, let me ask each of you, just go down the line here, but you know, you just saw my comments, but I'd like to get your view of the industrial Internet of Things, or whatever you think the future of cybersecurity challenges are. I don't want to make it so you're here for half an hour talking about that, but relative to what I just said, your views of it, maybe I'm way off base or not, but anyhow, to do that and at the same time tell the audience, you know, a few things about yourself and your company and what you do and things like that. So, Rich?
Sure. All right, I guess I'll start. So I'm Rich Carpenter, and
are these on? Is that on? Okay.
I think so. You hear me okay? Peter Lunk was supposed to be here. He apologizes he wasn't able to make it. He's with our World Tech division. I'm actually Rich Carpenter. I'm with the Intelligent Platforms division of GE, and we make a lot of the industrial software and the control systems that are used in many of our applications. So, you know, GE embarked a couple of years ago on the industrial internet journey, and we're pretty much all in. You know, it's more than $1 billion investment ahead of the curve from within GE, and it's sort of based on the premise that, you know, to support the $220 billion worth of backlog that we have for our equipment in the field, that we need to be able to connect to it, we need to be able to bring that data back to a central location, we need to be able to analyze it and provide a better service as a result of that to our customers. And, you know, we're clear that there's a large cybersecurity challenge there, both in terms of data privacy and in terms of the various threats that can attack various customer sites. And so we absolutely believe that you need to design the cybersecurity infrastructure from the ground up into the control systems, through the SCADA systems, and into the connectivity to the cloud. But we think it's inevitable that it's going that way because the cost to serve is a much better equation when you look at the cloud architectures from an elastic compute and storage standpoint. And more you can move faster and provide you know, what I would call fleet level analytics in that infrastructure that you couldn't do locally. So we absolutely see that it's critical and that it's coming, and it's a big part of the GE initiatives.
Xavier?
Hi, I'm Xavier Mesrobian. I'm with Skynet. I'm the VP of Marketing and Sales. You know, I would tell you that our position for the Internet, or the Internet of Industrial Things, for us started 4 years ago. Our founders have a deep root in Japan, and when they had the disaster in Fukushima, they had absolutely no idea why they didn't have remote access to that plant. And more importantly, why the hundreds of people walking around in the facility had these Geiger counters and they couldn't report the real-time data. Our basis is Cogent Real-Time Data Systems. Many of you may know us as Cogent Data Hub. We've been around for 19 years, and it's been really the focus of our team to develop a solution for the Internet of Things. And I will tell you, 3.5 years, 6 months of piloting, we finally released a platform which is a full end-to-end secure solution for connecting and networking any plants, any devices, secured by design, that keeps all firewall ports closed, or I should say out or inbound firewall ports closed, doesn't require a VPN, doesn't require any programming, and plug and play to any HMI or any SCADA system. So, you know, when you say how committed are we bet the farm. We're there. We believe we have a great solution. We just launched it 10 days ago for public consumption, and the signups are consistent every day. Thank you.
Hello, my name is Lior Frankel. I'm the co-founder and CEO of Waterfall Security Solutions. Our roots are related to Sid's presentation in the classic IT/OT integration area, securing that integration, or in a sense enabling it in a secure way. And in recent years, we evolved and expanded also to other areas in this really exciting area of cloud services and Internet of Things. We have developed some new technologies based on our experience in securing mission critical environments. And we have, by the way, a booth down there if you would like to see more information later on.
Good afternoon. I'm Dale Peterson with Digital Bond. We approach this issue and see this issue from a lot of different standpoints. Our consulting group works with owner-operators. Our labs actually test a lot of these vendor products, and then we, in our S4 conference, we work with kind of the bleeding-edge researchers or hackers, if you will, who are trying to break these things and publishing their results. So we see a lot of different points of view. The industrial Internet of Things is really hard to talk about generically because there's use cases, as Sid was talking about, or a taxonomy that we need to develop, and the impact on industrial cybersecurity varies quite a bit by that. We released some research in January showing how the progressive snapshot dongle, basically part of the industrial Internet of Things, could allow access to a car's CAN bus because it was insecure by design. It basically had no security. That's one aspect, and I think it was on the chart where you show customer or partner developed devices that are managed from a plant. Probably the most prevalent example in our host's documents has to do with sending industrial or control system or plant data out to the cloud for analysis for maintenance purposes, or perhaps to improve efficiency. And I think actually, if done properly, the impact of the industrial Internet of Things for that very important application is minor. It shouldn't affect the integrity or availability of the plant, and really you just need to worry about the confidentiality of that data. So in that case, I would say your major change or your major impact of the industrial Internet of Things would be confidentiality. But the key is, I think we need to start thinking about this as use cases or taxonomy and start to answer this question a little more granularly.
My name's Albert Roy-Akers with Bedrock. I spent 16 years in the process control industry, Foxborough and Benson Schneider, and did a major refresh with the IA series in the late 90s, and then I went to Silicon Valley to get into semiconductor industry for about 14 years or so, and decided to start this company called Bedrock, and start with a blank sheet of paper and try to bring the latest technologies to the control system domain so that it could start to ride the wave of Moore's Law and other things. So we started with a blank sheet of paper just a few years ago, and we have some stuff over here. So hopefully some of you or all of you can come take a look at it. But I wasn't really thinking about security as the concept of the industrial Internet of Things. I was just thinking of security relative to ICS. And are we allowed to just sort of respond to some of these things at the same time?
Please, yes.
So how much time? Can I just take the next hour or so? And
No.
No? You sure?
Nope.
Okay.
Yes, I'm sure.
Okay. Anyway, so the ICS and IoT is whatever. I don't get it, kind of. Because I think that a control system is a thing, right? So everything, which is really, it's an embedded device, should be secure. So what does that mean? It means that you actually have to start at the deepest layer within the technology, which is at the transistor level. So relatively new technology was driven by the financial transaction markets for embedded mobile financial transaction, but secure microtechnology, microcontrollers were developed, and they've progressed a lot. So you can't build a secure device, regardless of what it does. If it's an embedded computing device and it's not using embedded secure microcontroller technology, it's an oxymoron. You can't get there from here. So a secure microcontroller is very different than a standard microcontroller, and I don't want to, blabble you with details, but it's a very, very sophisticated submicron device that provides anti-tamper technology at the submicron layer. So that's the first thing that's required in order to build a secure device, whether it's the Internet of Things or it's an ICS, which is a combination of things that connect, embedded devices, I/O cards, controllers, and other things that connect ultimately into the cloud or the internet in some way. So that's where you start. The deeper the root of trust is, the more success you will have. And so when you design a secure product, a couple of questions you ask is, how valuable is the asset? Who is your attacker? And what are the consequences of being compromised? So the advantage/disadvantage risk-reward of the industrial segment is that all of the assets are valuable. They're machines, they're things that blow up, they're transmitters, they're valves that cost thousands of dollars. They're not a thermostat or a window sensor in your house. So that's good, so you should spend some money on it. Second thing is, your attacker is sadly, most likely someone that really wants to steal your assets or cause damage, like a nation state. So that's the other corner case. And then the consequences, they speak for themselves when things blow up and damage to property, but most importantly, damage to humans and human life. So the great thing is you can take a very serious approach with this. Now, some of you may have read Bill Leiden's recent article on emerging trends. If you start with a blank sheet of paper, you also get to address some other fundamental things like EMP. And I haven't seen this conversation very much because EMP can be a far more dramatic and catastrophic attack than a cyber attack, because an EMP pulse will destroy everything. And I wouldn't want 3 or 4 or 5 years from now to start to answer this cyber IoT problem. Then we're all sitting in a room trying to figure out how to solve the EMP problem, because the game's always going to change. Someone's always going to want to eat your lunch or cause damage. So EMP should be on the table. So you're going to solve the cyber problem, the EMP problem, and you're going to spend some money on it. Then you can do it in a very serious way. And the products start to look a little bit different. And the other thing is that once you do it right, although it's a new class of embedded engineers, they're new software engineers, they're crypto engineers, they're new hardware approaches. Once you get it done, once you figure it out, you shouldn't pay a cost premium for it. So when you come and take a look at the stuff, and I'll show you some stuff, some things, they're all here. It's all real, and we've built it. But it looks like several people have asked us, well, wow, what's the price premium for this? Well, it isn't. It's PLC DCS prices. Once you figure out how to do it right, it's not a cost premium. You just have to change the way things get thought and the way things get built. So that's it.
No, all right, and you really kind of started on my next question, but that's fine. I said you could. Okay. But since we've started on my next question, the thing I was going to focus on then was just ask the panel, what's a secure device, what's secure communications, and kind of work down through those elements that I mentioned. So, Dell, do you want to, do you all know Dell? I love Dell's blog, by the way, Digital Bond blog, but for years he's been writing about we need secure by design, quit being an apologist, right?
Well, a little bit. I guess a little twist on that is I wish the problem we had was that our systems were not secure by design, but actually what we run into is they are actually insecure by design. meaning you don't need to find a vulnerability, you don't need to find a coding error. You can use the features and functions in the protocols documented in the system to attack it. So your quote hacker, the hacking of control systems is actually the easiest part of it because you actually don't need to hack anything. You just use what's already there. Getting to secure by design is a lot harder than removing insecure by design. And you can very quickly determine if a vendor has done anything because that falls out pretty quickly. But what we usually look at is we talk to the vendor a little bit about their security development lifecycle. So Microsoft wrote the book on this literally, and do they have a threat model? Do they have secure coding practices? Are they doing fuzz testing? Do they have an internal or external third party look at this? And you don't actually have to look at all the data and understand everything they mean, but just looking at their security development lifecycle and how they've progressed through that can give you an idea of at least if they have a chance of being secure by design. And we're seeing, especially in the devices that don't look like computers, that aren't typically in plants, that whole philosophy of even worrying at all about security is kind of the same thing that happened with PLCs and RTUs years ago and other smart instruments. They just didn't even consider security at all. So it is going to be a major problem for those things.
Lior, would you like to comment? We can come back down this way, that's fine.
Sure.
Whoever wants to comment.
You know, the product that Bedrock is doing is in my opinion, amazing. Okay, I don't have share in their company yet, but I think that if you are looking at a like a cost performance or where to put your efforts first, I think that the main problem today is the design of the systems, the integration of all the products to one solution. So there's something wrong here. And I'm hearing a feedback.
Can you turn down the gain or something?
You can have a...
No, he's over there.
What?
The man that's controlling the mic, sir, is over there.
Okay.
Go ahead, speak into it.
Okay. This is a cyber attack.
Is it better now?
Yeah.
I didn't know what the problem
Okay.
was, but
So you know, you can have great products that are fully secure, but if you put them in the wrong way at a solution, at a system integration point of view, your overall system will be vulnerable, even if each and every product by itself is secure. Because a product isn't standalone. It's part of a solution. It's part of a process. And I think as Dale said, I think that most of the systems today, when they were designed, not the devices, not a specific product, but when you come in and design a solution for a plant, design a solution for a specific a need, security isn't part of it, or in many cases wasn't part of it, and fixing that is easier, can be done in many cases with external solutions, with solutions that augment existing systems, and can add much more to the overall security than retrofitting all the products with new and more secure products by themselves. And another perspective for that is, again, if you're taking an attacker for attacking an industrial site, the main target of an attack is to have an effect or have a remote control ability to affect the process, the physical process that's running in the control network. They don't really care about a specific product. You know, if there is one product which is secure, so they'll find a way to hack through another one. If the overall security is sound, the attack, the level of attack becomes really complex, and that's what I think the overall goal needs to be. So you can have a really good product, really secure, but you allow it to be remotely controlled by a vendor because that's what you do. So, we won't attack the product, we'll attack your vendor. And get through the process that you allowed him to do to remotely control your site. It's an approved process. Your ultra secure product can be remotely secure because can be remotely controlled. So, we'll go through that path.
Xavier?
Well, I'm going to go about this a little different. How many people here have a Nest thermostat? Put your hands up. Come on, don't be afraid. Only one?
I don't, but
Two. Okay, great. So here's the difference between something that's secured by design and something that isn't. For those of you who didn't know, the Nest thermostat actually contains your name, your address, your credit card information, and that information is not encrypted. I don't even need to take control of your house. I just need to take control of the thermostat, which, by the way, is clearly not secured. So, when you get home, you might want to take out your credit card because somebody eventually will get it. And this is well posted. I learned this a couple of weeks ago. I mean, one of the key things about secured by design, if somebody were to say, what does that mean? Well, I look at it really simply. As a child, if I was walking through school, if you wanted to prevent the bully from, taking your lunch money, make yourself invisible. That's the first thing. Invisibility cloak, if you could find one, would be great. But in the world of the Internet of Things, what it really comes down to is, A, security needs to be your top priority. It is the priority that you need to put above all else. You don't solve a business need until you solve security first. And from that perspective, I would say, for any device, you need to keep all your ports closed. No inbound firewall ports. How many people here have a VPN to their process control system? Anybody want to admit and put their hands up? Great. Did you all know that that is actually an attack surface on your plant? Of course. Do you have a proxy? Okay.
yeah, people don't divulge that information.
Right.
to
We
each
don't
other.
need. And while you're at it, I'm just going to check your badge. We'll just no. Anyways,
He's spear fishing.
Yeah, I'm spear fishing. At the end of the day, we want to just protect the fact that you want to keep the plant secure, and the best way to keep a plant secure is to keep your firewalls closed. So we have technology today to do that. The same thing applies with any connected device, any connected plant, any remote facility. We don't need to have VPN access into our plants. What we need is access to the data. So focus on the problem and don't circumvent security. And if you can do that, then you can build a secure by design solution as long as you remember that security is at the top and not a silo.
Great. I mean, I agree with many of those points, Xavier. I think some good ones there. I think you really have to consider the fact that control systems, independent of the Internet of Things, have many different attack vectors associated with them. When you add on the Internet of Things and the potential to connect outside of the firewalls, you have some additional care that you need to add. And the reason I separate the two is there's a lot of very positive outcomes that you can get through the Internet of Things. For example, we can just about eliminate non-productive time, which is unplanned downtime, on the big assets that GE provides to our customers by bringing the reliability data up to cloud infrastructure, running a set of analytics against it, predicting failures, and allowing people to have planned times when they can address those problems. This literally saves people millions of dollars in a typical year. And we'll publish catches of the week, every week, the number of saves that we're making to our customer base. Now, we can do that without having to completely change out the control systems that are in place and have been in place, because we haven't made the situation any worse. And this is where I agree with Xavier. If you're going to bring the data into a different cloud infrastructure, you need some type of a mechanism to do that that is invisible to the internet, that has no open ports, that has the ability to understand where it's sending information to, but do it in a secure, authenticated way and not have attack vectors from the outside. And we're very capable of doing that and have done it for quite a few years. On the control system side, I think that's going to take a little bit longer to put in place across all of our industries. Why? Because it's one, it's a kind of conservative industry. Two, people don't change out their control systems, every day. And three, the technologies are really just starting to emerge that make that possible. And we're doing the same thing within our controls, PLC, DCS type systems, making sure that the attack vectors around, is it running the right program, the program that we expect it to run? Is that actually what's there? How can we virtualize the control system and have a security watchdog that's part of the hardware that's sitting on top of it? How do we make sure that we're making use of trusted modules so that we can have certificates that exchange between consumers of the data and the suppliers of the data? And making sure that really any application that's connected to that type of information is actually an authorized application to connect to it. And so, I think that will emerge over time, and it'll make our plants more and more secure, independent of the Internet of Things. But, what I would hate to do is recommend to everybody to wait until that's in place before they start to make use of the great capabilities that are starting to emerge in some of these cloud-based systems. Certainly, we're not waiting. We're doing both at the same time. We acquired a company called WorldTech, which is a security expert, to shore up our overall systems. But we've been doing these remote monitoring and diagnostics, and now are starting to do operational optimization applications at the same time, and do it in a way that our own company is making sure is secure, because we're just as concerned about that within GE, as well as many of our customers. So I think you have to look at both problems and solve them, but they don't have to be serial in terms of the solve.